Have you ever wondered what makes your phone, your computer, and pretty much everything else in our modern world tick? It all comes down to a tiny, revolutionary invention, the transistor. This single device is the foundation of the information age, taking us from a 30-ton room-sized computer to billions of processors in your pocket. Before the transistor, electronics were in the old world, the age of vacuum tubes. Imagine a bunch of fragile glass bulbs, just like old-fashioned light bulbs. They worked by heating an element to create a flow of electrons, acting as a simple switch for binary code, the ones and zeros that computers use. But they had huge problems. They were bulky, fragile, generated tons of heat, and burned out all the time. The very first general-purpose computer, the ENIAC, built in 1945, needed 18,000 of these tubes. It weighed 30 tons and filled an entire room just to do basic math that your phone now does in an instant. Then came the game changer, the transistor. It solved every single problem the vacuum tube had. Instead of a clunky glass bulb, it used silicon, a semiconductor material. The real magic was its microscopic scale. While you could hold a vacuum tube in your hand, transistors could be shrunk down to the nanoscale. Today, a single chip in your phone, no bigger than a grain of sand, contains about 2 billion transistors. How does it work? Scientists found they could dope silicon with other materials, like phosphorus or boron. This created different layers, called N-type and P-type, which allow electricity to be switched on and off with incredible precision. There are no moving parts, no glass to break, and no warm-up time needed. So how did this tiny switch create the modern world? By acting as microscopic switches. Transistors form what are called logic gates. These gates are the fundamental building blocks of all digital circuits, allowing computers to perform the thinking that lets them add numbers, process images, and run complex software. This led to an incredible phenomenon known as Moore's Law. For over 50 years, the number of transistors we could fit onto a chip roughly doubled every 2 years. This exponential growth fueled the rapid explosion of technology from the 1960s all the way to today. But now, we're reaching the physical limits of the transistor. They've become so small that a weird quantum effect called quantum tunneling is becoming a problem. Electrons can sometimes leak through the barriers meant to control them, making the switches unreliable. Since we can't make them much smaller, the focus is now shifting from simply making computers faster to making them more energy efficient. And beyond that, scientists are exploring entirely new technologies like quantum computing to launch us into the next era of history. It's an amazing journey from a room full of glass tubes to the supercomputers we carry every day. Thanks for watching, and don't forget to like and subscribe for more.